Welcome back. Today we're going to be looking at a graph theory problem. If you haven't watched the string manipulation videos yet, I would recommend doing so first because we're going to be building on what we've learned there. So if we take a look at the problem, we see that we're going to be working with file directories, and in particular we're going to be counting how many directories need to be created. So they're going to tell us which directories already exist on our computer, and then they're going to give us another list of directories that may or may not need to be created, and we need to count how many of them do not exist. So for the input, they're going to be giving us t test cases, and for each test case, it begins with one line that contains two numbers, so n and m. The next n lines each give the path of one directory that already exists on your computer. The next m lines each give the path of one directory that you want to create. And for the output, we're just going to be counting how many times we needed to make a directory. So let's take a look at the sample input and output just to make sure that we have a solid understanding of the problem. So the first test case there, n is 0 and m is 2. So that means that there are no paths that already exist on the computer, and those two are being created. Note that we're not counting how many paths need to be created, but how many specific directories or folders need to be created. Alright, so let's begin to work on our solution. We'll name the class FileFixit. You can name it however you want though. And we need a main method. Scanner C equals. So here we have a scanner which will read in the input. First line of the input is going to be the number of test cases, so we can convert the next line to an integer. Alright, now we want to iterate through each of these test cases. So start at 1, go all the way up to and including t. Okay, now for each test case, the first line is going to be two integers separated by a space. So we can get that. So call this line equals scanner.nextLine, and we're going to split it by spaces. So the split returns it into an array. So in our case, the array will have two parts to it. So the one at the 0th index will be n, and the one at the first index will be m. So let's get these variables out. Convert it to an integer. And we'll duplicate this line and make the necessary changes for m. Alright, so now we know what n and m are. So let's just put in some comments here. So for the first n lines, we're going to be dealing with existing directories. I think it's a comment. And then after that, we're going to be dealing with m more lines, which are new directories. Okay. So let's make a for loop for this. For int j 0, j is less than n. So this loop will execute n times, and we'll want to read in these paths. So string path sc.nextLine. Okay. Now we're going to want to do the same sort of thing here, except with the variable m. And we can copy this line. Okay. So in here we're going to be dealing with all of the new directories that are being added to the computer. Now we need to start to think about how we want to represent these directories. I like to think of directories as a tree structure, which is a type of graph. So that's how we're going to be implementing this. So we're actually going to make another class, call it node, you could call it directory or whatever you want. And what's going to be in these directories is subdirectories. So we can use a list of nodes, and we'll call this subdirectories. And we'll just use an array list. Okay, I'll make this public. And we also need to know what the name of that directory is. So give it another instance variable, string. Let's call this directory name. Right, now we can make a constructor. And in the constructor, we're simply going to pass in the directory name. So this dot directory name equals directory name. Okay, so that's good for now. So go back up here. So now what we're going to need is some kind of root directory. So we can make it here. Root equals new node. The name doesn't matter. Let's give it an empty string. Now, we're going to need a new method in our node class which allows us to create directories. So I scroll down to our node class, and we're going to be adding a method here called make directory, and it's going to be accepting some kind of path. What we actually want to return from this method is an integer, which indicates how many folders or directories had to be created in order to make this path. And we'll worry about that return value later. So, what we want to do with the path that we're given is to split it into two parts. So, the next folder and then all of its subfolders. So we'll call this split path. And in order to do this, I'm actually going to use another method. So we'll just call the method split up path. And we'll pass it our path. Let's go down here and make a new method. So public string array split up path. It's going to take path. So first we need to make a new array, and the array is going to have two parts. So first we need to remove the first character, or the first slash, because that's not actually part of the directory name. So string equals string.substring. There's a few different variations to this method, but the one that will be most useful for this is the one that has one parameter. So what this means is that we're taking the string from the first character onwards, all the way to the end. So we're just getting rid of the first character, which is the slash. Next, we want to find the location of the next slash. So anything after that slash will be the subdirectories. So int index equals string dot index of. This is a very useful method. You can look for a substring inside of a string using index of, and it tells you where it starts. And if the string is nowhere to be found, then it is -1. So if index is equal to -1, that means that it has no subdirectory. So in this case, this directory's name, which we'll put in the first index, is simply path. I made a mistake here, this should be path as well. And here. Okay. And it has no subdirectories, so we'll just make this null. Just indicate that there are no subdirectories. And our other case is if it has a subdirectory. So in this case, the name of this directory is string.substring. I'll start at the beginning because the slash is already gone and go all the way up to index. So that's the index of the next slash. So this will give us our directory's name. And the subdirectory, string.substring, we're going to be starting at the index because we want to hold on to the slash, and we'll go all the way to the end. Now we're going to return this array. Alright, so that splits up the string into two parts, the directory name and subdirectory path. So I can just put a little comment here. Split string into two parts. Directory name and subdirectory path. Okay. So now that we have that method ready, now we want to check to see if this directory already exists. So let's iterate through our subdirectories. And for each of these directories, we want to check to see if directory.directory name is equal to the first part of the path. And for string equality, we need to use dot equals because string is an object. And if it's equal, that means we aren't creating a new directory, so we aren't adding anything to our list of subdirectories, but we're simply going to return this directory dot make directory. So this is a recursive call on another instance of this object, and we're going to be passing it everything except for the first part. So just because we didn't need to make a directory here doesn't mean that we might have to make another directory along the line somewhere. So this will account for that. And however many directories needed to be created will be returned. So I'll return an integer. So I'll add a comment above here. Check if subdirectory already exists. But if it doesn't already exist, then we need to create it. So let's make a new node. So node equals new node split 0. So that's the first part of the path, which is the new directory's name. And we want to add this node to our subdirectories. Add node, which is our new directory. And we're going to be returning 1 plus node.make directory split 1. Now the reason we're returning 1 here is because we actually made a directory. So if we didn't include this 1, then this method would only ever return 0 in our case. Now we need a base case. If the path is null, then we're going to be returning 0, because that means we've reached the end and there's nothing else that needs to be made. Remember, null came from our split up path method, where if there's no more slashes or no more subdirectories, then we indicate that with null. And this method is being passed the second part of that array, split 1, which could be null, which means we need to count for it here, otherwise we'll get a null pointer exception. So this is looking pretty good. Let's scroll back up here. So for the first n lines, we're creating existing directories. So what we actually want to use the make directory method, but we don't care about what how many folders are created by calling this. So we won't even take the return value. So root.make directory, we're adding this to the root, and we want to pass it the path. Alright, and now for the next M lines, we're looking at the new directories that are being created. And we're going to want to create a counter just to keep track of how many new directories were added. And we'll start this counter at 0. And we're going to be adding to the counter whatever this method returns, however many folders are being made. Okay, now we want to print output for this. We've used system.out.println, and we've also used string.format. What I forgot to mention is instead of using string.format and then printing that string out, you can actually use system.out.printf, where the F stands for format and works exactly the same as string.format. So we want to format this as case number, and then we want to stick in the case number, which is number, and that will be I. And then we want to give it another number, which is how many directories had to be created, which is our counter. And printf doesn't automatically put a new line character at the end, so we need to do that with \n. So I think this is looking good. We're going to try to compile it and test it out on the command line now. Okay, so let's try to compile it. Java file fixit.java. Look at our errors. It says here that the class interface or enum expected of the public node. So we look at our code. Yeah, I didn't make this a class, so this should be a class. But we're only allowed to have one public class per file, so we have to get rid of that. So we'll save this, go back to the terminal, and try to compile again. Okay, we're down to 9 errors. Cannot find symbol list. Okay, I forgot to import java.util, so we'll do that here. Both scanner and lists will need that. Try to compile again. 5 errors. Cannot find symbol split. This is on line 60. Okay, that makes sense. I should have called this split path. So that was a silly mistake on my part. I made the same mistake here and here. Save that. We'll compile again. 3 errors. Line 65. Cannot find symbol new node. Okay, I forgot to put a space. So do that. Try again. 2 left, 89 and 90. Cannot find symbol string. That's right, because we named it path. Okay, so we should be good now. Okay, it compiles. Alrighty, so I already went ahead and downloaded the small and large datasets, and I copied and pasted the sample input into a file which I named test.in. So we can run our program against that first. We'll feed it test.in. Alright, those answers match the expected output. So now we can go ahead and generate the files that we'll be uploading to Google Code Jam. Java file fixit. And we'll be feeding it a-small. And we'll output this in a file I'll call it a1.out. You can pick whichever name you want, of course. And I'll put the large one in a2.out. Alright, so now that we have our output, I'm going to head over to Google Code Jam and upload the files. Both of the files are ready now, so I'm going to submit. First one was correct. Second one was correct. Awesome. I hope you guys had fun with this challenge. It was great to dive into graph theory and explore recursion a little bit, and of course build on the string manipulation we've already been learning about. If you guys have any ideas for any programming competition problems that you would like to look at, feel free to comment below. Otherwise, I'll see you next time. Thanks.